In section 2.5b, we will be solving radical equations and absolute value equations. So let's start with, well, we've already solved radical equations from the previous sections, actually. So we will be covering the second part here, which is absolute value equations. Now, absolute value equations are equations where we have an absolute value symbol. So if you have an absolute value symbol like these ones, absolute value of 3, absolute value of -3, but if you have the absolute value including variable inside of it, then you're gonna have to treat it as an absolute value that we're going to go over the method of solutions in a moment. But let's talk about absolute value. Absolute value is as you know, it's the distance between a number and 0. Let's say, for example, absolute value of 3. Absolute value of 3, if I take 3 here, let's see the distance will be 1, 2, and 3. So that's why the absolute value of 3 is +3. Let's take a look at absolute value of -3. Absolute value of -3 is also 3 because this is -3 from 0, 1, 2, and 3. But the difference here is that you see how when you're looking for the absolute value of 3, it didn't change anything. Whereas the absolute value of -3, you had to, it's the opposite of 3, of -3. So to find the absolute value of a number when it's positive, the absolute value of a positive number is that number. Whereas the absolute value of a negative number is the opposite of that number. So the absolute value of a number when it's positive is that number, whereas the absolute value of a negative number will be the opposite of that number. That means, by definition, the absolute value of a number is, if the number is x, of a number x that I don't know its solution, it will be that number if the number is positive or 0. And it will be the opposite of that number if the number is already negative. So that's why the absolute value of -3 is the opposite of -3, which is 3. We've already said that an absolute value equation is any equation that includes part where the variable is between an absolute value symbol. And when solving an absolute value equation, we have to go through those steps. 1, make sure the absolute value is isolated. Remove all the terms, keep the absolute value by itself. 2, we eliminate the absolute value sign by using this property. So if I have absolute value of an expression u, equals A, then it will be the expression without absolute value equals A that create one equation, or the absolute value of the expression without absolute value equals the opposite of A. For example, if I have absolute value of 3x minus 5 equals 7, that will be equivalent to 3x minus 5 equals 7, or 3x minus 5 equals negative 7. So, and then we would solve these two equations, isolate the value, the variable from each equation. Then we must make sure we check for fake solutions or extraneous solution. Let's go through these examples. Example number 1, we're solving the absolute value equations, and if we have multiple solutions, we would separate them with a comma, and if there's no solution, we'll put DNE. To solve the first example, we can add 2 on both sides to isolate the absolute value. Then we'll have absolute value of 5x plus 6 equals 9. Now we can create two equations, 5x plus 6 equals 9, or 5x plus 6 equals negative 9. Then we can subtract 6 on both sides for both equations, and then we'll get 5x equals 3, or 5x equals negative 15. If we divide by 5, we get x by itself. We would have the two solutions. One is x equals 3 over 5, or x equals negative 3. Now we're going to check to see if we have extraneous solution or a fixed solution. Let's see. We're going to check the first solution. We're going to check this one. So that's going to be absolute value of 5 times x, which is 3/5, plus 6 minus 2, is it 7? So that's absolute value of, you cancel 5, that's 3 plus 6 minus 2, is it 7? Absolute value of 9 minus 2, is it 7? 9 minus 2, is it 7? 9 minus 2 is clearly 7, so we have 7 equals 7. This one checks. That means x equals 3 is a solution of the equation. So let's check for x equals 5 over 3 is one of the solution, verified. Let's check for x equals negative 3. We'll have absolute value of 5 times negative 3 minus 2, negative 3 plus 6 minus 2, is it 7? Absolute value of negative 15 plus 6 minus 2, is it negative? It is 7. Absolute value of negative 9 minus 2, is it 7? And then 9 minus 2, is it 7? 7 is 7. So we have both of the solutions, they work. they verify my equation. So we can give the solution set that is 2, -3, or 3/5. Now let's see the next example. Make sure you cannot combine -2, 1 and -2 in this case, because -2 is a coefficient for the absolute value, multiplies the absolute value. In order to cancel that absolute value, that -2, you should divide by it. And to cancel that 1, you should subtract it on both sides. So pay attention to this. So that is -2, absolute value of -9x plus 5 equals 8. Then we divide by -2 on both sides. Then we get -9x plus absolute value of -9x plus 5 equals -4. Now, because the absolute value of any number is always or is never negative, the equation absolute value of -9x plus 5 equals -4 has no solution. You would have a solution set that is DNE. Solution does not exist. Well, on a test, for example, you would need to write the sentence or solve the equation and verify, just like we did here, that the solutions, all the solutions don't verify the equation. So that's why I do this one this way. I believe the next one will be the same scenario. Then we're gonna do it the other way, so you can pick your choice, but you can't just say DNE for after you get X absolute value negative. You should explain clearly, make a complete sentence to explain why the solution does not exist. The next example here, let's subtract 5 on both sides. That is 2 absolute value of 6 minus x equals -2. Then if you divide by 2, you're gonna get absolute value of 6 minus x equals uh -1. Now we're going to try to solve it by creating the two equations. 6 minus x equals -1, or 6 minus x equals 1. Now we're going to subtract 6 on both sides. You get -x equals -7, or x equals 7. Subtract 6 on both sides. -x equals -5, x equals 5. Now we have the two solutions that we're going to check to see what happens. Well, we clearly know that both solutions will not work. We're just going to prove they don't work. It's not just knowing they don't work only. You have to prove, explain in words, or prove it. So I did one example where I explained it using words, and this next example I use the the same steps we would solve the equation when if it had solutions, you can process the same way, but check the solutions and verify that none of them verify the equation. So let's verify this one. X equals 7. That would be 2 absolute value of 6 minus 7 plus 5. We wonder if this is 3. Now that is 2 absolute value of -1 plus 5. We still wondering if this is 3. That's absolute value of -1 is 1, so that's 2 plus 5. Is this 3? 7 is not 3. So this is not, x equals 7 is not a solution. Now I'm going to try to see if x equals 5 would be verified, but we know it will not, because we already know that this equation has no solution, because absolute value, it has always a positive result. So x equals 5. It would be 2 absolute value of 6 minus 5 plus 5. Is it 3? 2 absolute value of 1 plus 5. Is it 3? 2 absolute value of 1 is 1 times 2 is 2 plus 5. Is it 3? 7 is not 3. So same scenario here. For x equals 3, x equals 5 does not verify the equation. X equals 7, x equals 5, both of them do not verify the equation, so the solution does not exist. Now let's go with the next and last example for absolute value equations. We can add 14 on both sides. That's 5 absolute value of -9 minus 9 over 7x equals 20. Then if we divide by 5, we will get absolute value of -9 minus 9 over 7x equals 4. Now we're gonna make up the two equations. -9 minus 9 over 7x equals 4, or -9 minus 9 over 7x equals -4. We have the two equations. We're going to solve them separately. Let's add 9 on both sides. We get -9 over 7x equals 13. If we add 9 here, we will get -9 over 7x equals 5. Now what I would do is I would multiply both sides of the equation by 7 here, and I'll do the same thing over here as well. -7 actually, by -7. Then I get here that cancels 7 and the negative sign. I'm left with 9x equals -91, and then cancel -7. I'm left with 9x equals -35. And then by dividing by 9, I will get x equals -91 over 7 here, or x equals negative 35 over 9. The first solution is negative 91 over 9. And the second solution is x equals negative 35 over 9. Now let's check both solutions, because we don't know yet if they would work until we check them. Let me check for x equals negative 91 over 9. That is absolute value of, that's 2, absolute value of, it's 5. It's 5, absolute value of negative 9 minus 9 over 7 times negative 91 over 9 minus 14. Is it 6? We're going to perform the part inside of the absolute value. We have the negative sign and negative sign. They give a positive sign. We can cancel the 9. And then 91 divided by 7 is 13. So that's going to be 5, absolute value of 9 plus 13 minus 14, is it 6? So that's 5, absolute value of negative 4, positive 4 minus 14, is it 6? Absolute value of 4 is 4, so that's 20 minus 14, is it 6? That 6 equals 6. X equals negative 91 over 9 is verified. So this one checks. We're gonna try to do the same thing for x equals negative 35 over 9. So that's 5. So that was the first one, and that's the second one. Absolute value of negative 9 minus 9 over 7, minus 9 over 7 times negative 35 over 9 minus 14, is it 6? We do the same thing here. I'm going to minus is a plus, cancel the 9, and 35 divided by 7 is 5. So that is 5, absolute value of negative 9 minus plus 5, absolute value minus 14, is it 6? That's 5, absolute value of negative 4 minus 14, is it 6? And then absolute value of negative 4 is 4. So that is 5 times 4, that's 20. 20 minus 14, is it 6? 6 equals 6. This one also verifies. So we have both solutions that verify, and the solution set here is both solution. Negative 91 over 9 or negative 35 over 9.